Is any real number exactly 3 more than its cube? So let's start with the real number. Let's call it Mr. X. Let's use a different color, something I haven't used in a while. Let's use blue. Let's call the real number X. Its cube would be X cubed. If X is exactly 3 more, then X minus 3 would have to equal X cubed. And if we want to get all the terms to the right-hand side of the equation, let's do the steps. Minus X plus 3 to both sides, minus X plus 3 to both sides. We would have 0 is equal to X cubed minus X plus 3. So we want to know, when is this function right here equal to 0? Then we would have a value we would have a number whose value is exactly 3 more than its cubed. So X cubed minus X plus 3, I have this graphing calculator here. Let's see, X cubed minus X, what did I say, minus plus 3. Plus 3, evaluate it, and yes, it would have that function has 1, 0, and I cannot get exactly right there on the graph, but it looks like it's like 1.6 or something. And you would have to know how to use your graphing calculator to use some kind of solving function, and I can't help you with that right now because I don't know how to use it myself. Find the power function end behavior model for the function f of x is equal to all of this. Okay, so end behavior is as x goes to positive or negative infinity. So as x goes to positive infinity or x goes to negative infinity. Negative infinity. So as you look at this, the terms that will dominate will be these highest power terms. 3x to the fourth will dominate anything that 2x to the third will contribute to the value of the numerator, because we're taking these larger and larger numbers, whether the positive or negative, to the fourth power. So the power function will be I hope I'm saying this right, would be 3x to the fourth over 2x squared.
Trojan. Here at our lab, we've combined the Trojan X.
And so if this is the end behavior, you can see that it doesn't matter if x is positive or negative. It's x to the fourth over x squared. Both of these terms are going to be positive because they're positive. They're an even exponent. So this x to the fourth will clearly dominate x squared. So we have 3 halves x squared. You can also see that algebraically. You would just cancel them. You would cancel 1x squared with one of these. And as x goes to positive and negative infinity, this value would go to positive infinity. Although I think that's not the answer to the question. The answer is 3 halves x squared, I believe. Find a right end behavior model for the function. Right end is as x goes to infinity, right? So here we are, and as we shoot out to the right, because we're talking about right end model, x is going to infinity. Remember, e to the minus x, e is just a number, 2.71 something. This is equal to x plus 1 over e to the x. Well, as x gets larger, it should be an equal sign, as x gets larger, this term right here goes to 0, and we eventually just become more and more like a line. So I would say the right end model behavior is like y equals x. Verify that your answer for number 26 is correct. I don't know. I think I just did. Oh, maybe that means to graph it, and maybe do resize the window. I'll have to get back to you on that one.